From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 220, recorded live Thursday, July 1st, 2010. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Pete Brown, Larry Larsen, Jeff Kirkham, and Chris Kirk about creating the ultimate developer machine.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. And on this week, we are trying to build the greatest computer in the history of mankind. In fact, we want to build God's own computer, the good Lord's own computer, with all due respect. Specifically, a computer that is going to be a great developer machine. We have a limited budget, a little bit more than the average computer. Our budget is $3,000. But we want this machine to hit 7.9 on the Windows Experience Index. So I've got some experts from all over Microsoft to help us do this. We've got Larry Larsen, hardware expert from Channel 9. How's it going, Larry?
Great.
Larry has the flu, so if you hear anyone hacking up a lung in the background, that's Larry. Larry, you may remember Larry from the PDC laptop. He helped work on that. We have got Pete Brown, hardware enthusiast, who started overclocking Commodore 64 when he was 6 months old. Hi, Pete Brown.
Hey, Scott.
And then we have Jeff Kirkham, who is here from the WinSAT team. He's a developer who actually works on this index. He actually knows about how to measure these things. How are you, Jeff?
I'm doing fine. Glad to be here, Scott.
So we've got a pretty broad group of enthusiasts here. We've got our people from deep inside of Microsoft who are going to help us make this happen. Why don't we start by finding out what is the Windows Experience Index? Larry, can you explain kind of like what's the point of this number that measures how fast?
Sure. The Windows Experience Index is a overall system assessment tool used to figure out if your hardware, what its base speed is. It runs a series of tests on your computer, and those give you subscores. And then out of the subscores, the lowest score for your one of your system's components will be your overall WEI score. The idea being that the system is only as fast as its weakest link. And so running this tool will give you an overview of how fast your system is. It was introduced in Vista, and it went up to 5.9. And in Windows 7, they raised the score up a little bit, so it goes up to 7.9.
Okay, but this is an arbitrary number. This is not megahertz. It's not anything. It's just like my number. My machine's a 6. 6 what?
It is.
It's just a 6.
It's not really an arbitrary number because you will get the same score basically every time you run it. And it goes up a little bit and it goes down a little bit depending on the efficiency of your drivers as well.
Okay. So I'm looking at my machine here. I'm just going to the Start menu, right-clicking on Computer, and hitting Properties. Another way you can do this, I think, is you can hit Window Break. And it says here Rating 5.9, and I click on that. And my machine has a 7.1 processor, 7.1 memory, 6.7 graphics, and a 5.9 hard drive. What does this tell me about my computer, Larry?
Well, it tells you that your weakest link there is your hard drive, and that's usually the case from what I've seen on different machines.
Mm-hmm.
So you could upgrade your hard drive and bump your score up a little bit. That'll bring your entire system score up a degree, depending on what kind of hard drive you put in it.
Mm-hmm. And how do I know if this is a good number? I mean, is this printed on software? Do I go and buy a copy of World of Warcraft and it says if you don't have a 5.9, you're a loser? Or what good is this number other than telling my friends?
Well, there's a couple things that you can glean from it. I mean, first of all, you have to have a 3 or higher to have Aero Glass, of course. It depends on what you're doing with your machine. If it's a business machine, then, a lot of people will say 3 is okay, probably the person that's doing purchasing for your hardware in your department. I would say probably a 5 or a 6 is a little bit better. A 5 if it's a laptop, a 6 or a 7 if it's a desktop. But of course, all of us want the absolute highest score that we can get. One of the things that we did in DPE is we had a Coding for Fun project called WEI Share, and you can get to it at weishare.net. And this will allow you to run your Windows Experience Index and then submit your scores up to the cloud, and it goes up to an Azure site. And then we can use that to try to see what different scores various machines get. So you can go up there and get an idea of some of the faster machines and what kinds of scores they get. I would say if you're at a 6, a 6.5, or a 7, you've probably got a pretty good machine, at least for entry-level gaming.
Mm-hmm. So I suppose that if I look at this and I have like a 4, and then I look at my numbers and it's like 6, 6, 7, 6, 4, that's a pretty obvious example where I should look at that one low component and potentially update it.
That's a pretty weak link, yeah.
Okay, so, interesting.
Scott, can I step in real quick?
Please.
This is Jeff. Just to clarify on how these scores are done, you need to think of the digits on the left as a class of machine, and the digit on the right as a linear number within that class. So going from a 6.8 to, say, a 6.9 is not the same as going from a 7.8 to a 7.9. That line, once you get to a given class, is a different slope to that line.
Interesting. Is this kind of like the Richter scale in the sense that a 6 is 10 times faster than a 5?
No, it isn't. I wish it was simple to explain like that, but it's not. It just is important to understand that we're dealing with classes of numbers rather than one long scale that goes from 0 to 7.9.
Okay. So
would a 7 be that much better than a 6.9?
Yes, you would be stepped up right there.
Cool.
Interesting. So that's very interesting. So I've got these class 7 processor, class 6 graphics, and I've got a hard drive that's just working its little butt off at 5.9. If I updated that to a better hard drive, then it would take my machine to a whole other class and potentially make things a lot easier.
Yeah, I actually think even in that case you would notice it. And clearly, if you put an SSD in there, you're going to notice it.
Okay. All right. So Pete Brown, what is our goal? What is our goal in this machine? We've both gotten permission from our respective bosses, specifically wives, to build these machines. I've allocated some of the funds at this point.
And there was sufficient eye rolling as part of that.
There's another name for that boss. It's a common name. It's called She Who Must Be Obeyed.
Right.
Pretty much.
So there are a couple of goals for what we're trying to do here. The first is just to build a really awesome machine, right? And you can build a really awesome machine that's a 7 class, just like we learned here, and maybe it's a 7.5, and I'm using my machine and it's worlds better than what I'm doing now, so I'm pretty happy with that. But then there's this whole kind of, I want to hit 7.9 just because it's a number that can be obtained, So when I was in high school, I took my mother's car down a very steep hill along a long ways just to max out the speedometer, but it wasn't because I was in a hurry. It's because there was a number at the end of that speedometer, and I wanted to see if I could hit it. So, there's definitely some just because aspect to this. And truthfully, getting to a 7.9 is going to mean you're going to have a really, really good machine, right? Plus, Scott, you have a 30-inch display and a bunch of displays, right?
Right.
Yeah, and I've got the same thing, 30-inch. I've got a couple other monitors. So we're also looking at something that needs to be pretty heavy on the graphics department to push all those pixels. So I know I've read some of the comments on the blog and stuff that said, why are we building kind of the world's best gaming machine here when we're not, huge PC gamers? We have Xboxes, and that's what we do most of our gaming on. But it's not just about, gaming graphics. It's about pushing more pixels, being more efficient in Visual Studio, opening more applications at the same time. So, more cores is better. Having, more instances of Visual Studio open and compiling. Doing things like video encoding, which is a big task we do on our team a lot, that we use as many cores as possible and as fast as possible. So there are a whole bunch of different things here that pile into, the use of this, in addition to just the fact that we want to hit a 7.9.
Well, doesn't that mean, though, that you're optimizing for a moment in time that's not very common? There have been times on my little 5.9 machine here, which, by the way, was the ultimate machine 3 years ago when I built it. When I built this machine for Vista, this was the greatest machine. And at this point, it's not. But there have been times when I've had 2 or 3 versions of Visual Studio open, Outlook, 20 browser tabs. I've been literally capturing video from a video camera, squishing video. I mean, I've had those moments. Am I optimizing for that moment where like twice a month I'm using the machine to its fullest?
Maybe there's a bit of that, right? So it depends on how much that time is worth to you, right? If you're doing the video encoding and it's a difference between sitting down for an hour or sitting down for 20 minutes, that can be a big deal on that particular day, right? And it also just it leads to a sense of satisfaction. If you're using your computer and you look at this process that you know is going to take everybody else 2 hours and only takes 20 minutes for you to run, it just makes you feel good about what's sitting in front of you.
Okay.
Plus, we're people that have built our PCs for pretty much every PC since way back. The last PC that I actually bought was a 286. And so there's something to be said about a machine well built that kind of maxes things out as much as possible.
Okay, so we know the goal. People may or may not agree with the goal. But there's some interesting questions on Twitter here, like what percentage of the cost are we estimating is going to be used to go from like 7.8 to 7.9? Because it seems to me from the discussion on the blogs, you and I, Pete, blogged about this, that it's pretty easy to go and just spend a lot of money and get a 7.5, 7.6, 7.7. It really requires very little skill or effort. Are we going to spend a lot of effort trying to get an extra point or two? And to Jeff's point, we've already got a set class 7 machine.
Right, and I don't know how, some of those things are the price of the various components, I was looking at processor prices, and so like the top of the line i7 6-core is $1,000, and then the step down from that is a 4-core, and it's like $500 or $600, somewhere around there.
Mm-hmm.
And if you go a couple of steps down and still, stay within the 3 gigahertz range, you're still looking at around 500, right? So that's about, you're paying about 2x to get a super fast processor with extra threads if you're interested in that. But I think the biggest cost here, and you guys correct me if I'm wrong, but I think it's going to be the drives, the SSDs. We were looking at, what it takes to be able to get a 7.9 on the SSD drives, and it looks like it might actually be a pretty intense process, like having multiple SSDs using like a RAID 0 striping or something, which in and itself is kind of scary, but it will get you that performance. Unless you want to go and spend, I was looking at Newegg earlier today, and I saw the 10 grand OCZ SSD that just came out. It's 512 gig, does like 1,400 megabytes per second or something crazy like that, but that might be out of budget.
All right, well, let's do this. Let's talk about, let's have Jeff explain what is the subsystem inside of Windows that is doing this measurement and kind of how that works, and then we'll talk about parts that we're going to build.
Okay. The program that actually runs underneath the UI is WinSAT EXE, WINSAT. It's in Windows System 32. You can run it from the command line. If you run it from the command line and give it just the word formal as your parameter, that's exactly equivalent to what the UI is doing. So if somebody's out there maybe overclocking with some of the newer tools that let you overclock while you're in Windows, you could have a command window open. It'd have to be with administrator rights. Run WinSat EXE formal, and you'll be able to get your scores right there on the command window and see what they are. So you don't have to keep going back to this UI to run the system if you want.
Okay. Now, WinSat, I remember, runs when I've installed Windows. Like, I install Windows, I run through the setup the very, very first time, fresh machine, and it runs right away. What is it looking for? Why does Windows care so bad that it would run this immediately upon boot?
That's really because the DWM is dependent on that, the Windows Manager, to determine whether you get Aero Glass or not. They depend on the numbers that we come up with in our scoring system. So that's why it runs then. And then every week on Sunday night, it pops up again and runs to determine if you've changed any of your critical hardware. So if you've changed any of that hardware, it can re-evaluate your scores and update your scores for you.
Okay. And this is used anywhere else? Is it only used to update that number and then to help me make?
No, there's a couple other places, particularly now that we've got the SSD drives. We want to make sure that if we detect there's an SSD there, that we shut down the disk defrag. There's no point in running that. It's just going to wear out the drive. Superfetch is another one where we basically just disable Superfetch if we find that the drive is fast enough to handle the requests during boot that we don't need a Superfetch. So we do have a couple of features in Windows that are dependent on us.
Okay. So more and more people are becoming dependent on knowing about this score so that they can make decisions about whether or not they want to run a certain thing. Can I query this? Can my application ask questions of the Windows Experience Index and make decisions based on that?
Sure. There is on MSDN. There's full documentation for an API where you can get the scores. You can also do an XPath query into the XML that we've stored all the data in. And then there's actually a WMI provider that you could use also that's pretty fast. If you happen to be good with PowerShell or something, you can pop that open and get the scores really fast that way too.
Oh, I didn't realize that was an XML that was really easily accessible. I think that Pete and I just got an interesting little bit of code we can write there then to check that out.
Right.
Yeah, there's actually, that XML's got a lot of data in there, system configuration data. It's kind of interesting to look at. I hope people wouldn't mess around with it when they're in there, but it is interesting to look at.
Oh, people will mess around with it now that we know about it.
One thing to keep in mind, too, is WeShare is open source, so if you want something to start with, you can certainly try that.
Cool. So all the code that does what we need to do is in the WEIShare.net code. And is that at codeplex.com/WEIShare?
Yeah, that's correct. It's WeShare.codeplex.
Okay, cool. Okay, so the machine we're going to build, let's start at the processor, guys. What's it going to take to get a 7.9 processor today?
So from looking at what was uploaded to WeShare, it looks like you need to be overclocking at like 4 gigahertz plus with at least a quad core. Does that sound about right?
I think that's the stuff that we came up with. I think a person might be able to get by with a lower speed if they had more cores, because we do take that into account in measuring, and the more cores will help boost that score.
Okay, so burning out a 6 core is not a requirement for getting a 7.9 on processor.
This is Chris. Mind if I step in on this one?
Yeah, Chris, thanks.
Okay, hang on. We just had someone show up here who wasn't introduced at the beginning of the show. Who's on the phone now?
This is Chris Kirk. I'm also one of the engineers on WinEI.
Awesome. Hi, Chris Kirk. Thanks for joining the call.
Hi, thanks for having me. So the thing about the CPU score is that we combine your single-core performance as well as your multi-core performance, since not all applications use one or the other. So having more cores will definitely help out, but there's a certain limit. You must be at least so fast on a single core.
Okay, so I'm hearing when I look around the blogs that 7.7.7.8 is pretty easy to get. Are we just at a moment in time right now where 7.9 is not easily bought off the shelf? Or do I just need to go out and buy 2 quads and a dual process, like two separate quads and build an 8-quad machine to get to 7.9?
It's designed to be a little bit future-proof, so it's something that's reachable today if you overclock, but given tomorrow's hardware, will be a lot easier to reach.
This is the part of the show where I mock you. Well, actually, Telerik mocks us. Your applications that you're testing dependent on external systems over which you have no control. Maybe you're being slowed down by those systems, their lack of availability, responsiveness. You want to do TDD right? Our friends at Telerik help you solve some of those problems with their newest mocking tool, Just Mock. It'll let you do fast, simple, controlled unit tests independent of external resources like databases, web services, proprietary code. Unlike some mocking tools, Just Mock works with non-virtual methods, sealed classes, static methods, giving you complete control of your code. You can get more details. You can download Just Mock at Telerik.com/JustMock. And don't forget to thank Telerik for supporting Hansel Minutes on their Facebook fan page, Facebook.com/Telerik. Thanks a lot. Would you guys say as a collective that for the ultimate developer machine that we need to go and get one of the new 6-processor machine, the hexacore, or should we just go with a quad today?
If you're comfortable with overclocking, you can do it with a quad core and use the extra money to put into the disk array.
Okay, so we're already jumping ahead because we're assuming a disk array, so that's very interesting. My only thing is that I think Pete and I have both had the conversation that if we bought a quad, we might just be sad because in a year or two, you're going to be able to pick up a hexacore machine, a 6-processor one for like, $9 at the local gas station. So we're just kind of wondering, I already have a quad.
Yeah, I would build 6-core just because I want one, but...
Yeah, there's definitely some geek pride involved here.
Some geek pride. Okay, but aren't they harder to overclock?
Not really. The 980X is designed to be overclocked, so...
Okay, so 980X. That's the one that keeps coming up. This is an i7 980X?
That's right.
We had a couple people on the blog say we should do an AMD, but more and more people are saying that this 980X just is meant for overclocking. Yeah,
what I've usually heard is the AMD is good, like price performance, but if you want kind of top of the line, the 980X right now is it's 3.3 gigahertz, I think, and it's using the 32 nanometer process, and it's just optimized for overclocking. And folks are getting this thing way up over 4 on. Some doing some stuff short term on air cooling, but mostly on liquid.
And what's the price on something like that then?
Yeah, so that's $1,000. That's sort of the hard part about it.
Wow.
See, that's the thing. It's a third of our budget, and people are saying, well, you could get us basically the same one for half the price, and just get why do you want to work so hard to get that that 0.9?
So you think at 500 we could hit maybe 7.6, 7.7, something like that?
It's closer to 600, and I think you can overclock it quite a bit, and or maybe not have to overclock it as much as some of the previous generations, but overclock it enough to be able to get the 7.9 if you want to. So, like for a pure 7.9 stuff, I personally think you can do it on a cheaper processor. But I look at $569, which is what I see the price is, versus $999. I'm thinking, what price for my happiness is $400 worth my happiness?
Yeah, that's a lot of lattes you could buy for $400. And the other thing is that, at this point, remember in Vista, the WEI score was maxed at 5.9. It's maxed at 7.9 currently in Windows 7. I don't know when I hit 7.9 if there's really if I'm an 8 or if I'm some theoretical number that I can't see yet. But if I buy a $600 processor and then push it up to 7.9, I feel like maybe I'm like wearing lifts in my shoes, and I'll always know I'm not really that tall. So then whenever the numbers do go up in the future, we'll find out that really I've been walking on my tiptoes all this time. Larry points out here on the chat that there's a Core 2 quad that's getting a 7.9 that was a $300 processor. So I think that with overclocking, it sounds like that we have actual proof from the WEI Share website that you can take a quad Q9650 and take it up to 7.9, really standing on your tiptoes, but you can do it for $300. So that's really going to be a tough decision for Pete and I to make, I think.
And that one, when I looked at the data, that guy's got, or that person has that, I think those are normally like a 3 gigahertz processor. He's got it going at 4.3, so I'm pretty sure they've got a pretty high-tech setup going there.
So the 4, we need to get to the 4 gigahertz speed, it looks like, in order to even think about 7.9.
Yeah.
Yeah, I think
that's $300 is pretty compelling.
Yeah.
Okay, so 4 gigahertz, we're going to have to, I don't think we're going to be able to make that decision here, but I think I'm going to want to lean towards spending a little bit more money. I mean, it's not every day that I get permission to spend money, and I think I'm leaning towards a little bit more expensive processor just to future-proof myself, and I really like the idea of a 6-proc. But it sounds like the processor is definitely going to be the challenge. Now, memory, usually when I put together machines, the memory is always the same score as the processor for me. I know that it changes on lower machines, but is it really going to be very hard for the memory to get a high score as well?
If you get enough of the memory, you will do that. There is a connection between the CPU score and the memory score. They kind of depend on each other a little bit, but if you're going to build a 64-bit OS machine and you get enough memory on there, then your memory score will be independent of the CPU.
Okay. So do we think that this is, I mean, I've got 8 right now, and it's fine unless I'm running a couple of VMs and Outlook and, how does, do I want to go 12 or do we want to go 16 here? Is 16 a little crazy? Thoughts?
Go ahead. Chris, do you know?
It really comes down to what sort of applications you're planning on running. Since this was going to be a developer machine, you're going to be building a lot of code. For not a whole lot more money, you can switch to 16, so why not?
Okay. Is that enough memory? Do you think what is enough memory now?
For me and stuff I do, 12 gigs is enough. But tomorrow, who knows?
Okay.
Can I throw a wrinkle in here?
Please.
Sure.
So if we're looking at triple channel memory, then you're looking at getting 3 sticks at a time, in matched sets, right? So that means you're probably looking at either 12 or 24.
Wow. Could we fit 24 in our budget?
I don't know.
Wow.
I haven't priced memory. Every time I price memory out, it's like 100% different.
Well, see, this is the thing about memory is that, they're like Larry says that there's 7.9s that have 6 gigs of memory, but I mean, no one here would propose that 6 gigs would be enough for the ultimate machine. I mean, I have so many tabs open in my browsers. I've got Outlook, I've got TweetDeck, I've got MetroTwit, I've got all this different crap running. 12, I think, is my minimum. If I could get 24, that'd be awesome. But I want to have to see the pricing on that.
Well, plus if we get a board that has six slots, you're looking at, you can get 12 now if you get like 3x4. And then if you want the other 24, you can slip it in under another project, right? Or the other 12.
Okay. And what am I going to have to do at the motherboard level to make sure I could do 24?
You need to make sure the board has enough slots to do 24. And I think that most of them will, these days at least, do it, but it's worth double checking.
Okay. All right.
I personally think I'm going to start with 12.
You're going to start with 12? You're not going to even think about more than that? And there's no way to get to like 16 or something like that?
There is, but you start losing some of the advantages of triple channel. And don't ask me what those advantages are. I just know that match sets with the three sticks is a good thing for performance, but I haven't done any actual measurement.
Okay. This feels like back in the day when we were doing 286s and 386s, and you had to have memory in a certain order, and you had to have a certain number of sticks. And are we back to that again?
Well, kind of. They're selling these things as matched sets where they're all timed the same and they're all the same quality to kind of make sure that you don't get one stick that's a lower quality than all the other ones and have it bring down the rest of your system.
Tricky. Okay. Now, interestingly, with the WEI, with the Windows Experience Index, you've got processor and memory. Those are separate scores. And then there's hard drive. But then graphics and gaming graphics are separate things. So desktop performance and 3D performance are two different things, which always implied to me that some video cards are really great at moving transparent windows around, and some video cards are great at pushing polygons around. But in my experience, it's always been the same score for my video cards. Are those really so important that they need to be separate, Jeff or Chris?
I think that I would tend to say that they probably aren't that important to be separate things. But again, we needed a test for the desktop Windows Manager, and we did want to get a good 3D test in there too. So I think that's how it kind of evolved into two separate scores, one particularly for gamers, and then one just a general desktop video score.
So I have a question on this because the awesome machine that Scott had sent to me when I first joined does 5.5 on gaming graphics, but a 4 on Aero. So I'm trying to figure out what kind of scenarios are there, and what are we looking at where the business machine here is better at gaming graphics than it is at Aero?
That is an interesting question, because I find that the more monitors that I have, I feel like my machine is slower. I've got 4 monitors, and one of them's a 30, and I'm running an NVIDIA 275. And when I added that 30-inch monitor, things just felt slow, but my graphics score is a 6.7, which is pretty respectable, I would think, at least for pushing two-dimensional windows around. Any thoughts on that, guys?
Well, of course, it could always be a driver issue, but certainly the more real estate you have, the more windows that you have open, the more that the graphics on the system is going to get stressed.
But moving Aero windows around, I mean, really any video card will do, won't they, these days? I mean, when I think about video card performance, this is a developer machine. I don't want to optimize for 3D graphics. I want to optimize for minimizing time. I want to optimize for not ever having visual tearing as I drag a window or resize a big window. So I think I want to point out that I want to optimize for 2D, not for 3D, for myself. Because this is a developer machine.
I have to agree with Jeff on this one that with the modern operating system, there's more and more 3D graphics, even just in opening up Internet Explorer, wandering around, moving between things like the Start menu tab option, and you need a little bit of both.
This is tricky. Should we only use one monitor when I am running the WinSAT test?
It shouldn't matter.
No, I don't think that's going to matter.
Okay. Well, that's good to know. I always wondered if I should just switch to 1024 and run the test to get myself a better score.
The graphics is rendered off screen, so the actual resolution on your monitor shouldn't have any impact at all.
This is good insight then. So people are saying that the NVIDIA video cards, NVIDIA in the, I think 480, I think is the model number, is a really good one. And if you look at WEI Share, they've got DirectX 11 support, and they've got a 7.9. It's the NVIDIA GeForce GTX 480, except apparently it runs really hot. We're already talking about water cooling the processor. Are we going to have to water cool the video card? That sounds like more hassle than it's worth.
There's a good chance you're going to want to water cool the video card. We can't say for sure whether you need to overclock, depending on which video card you get. I don't think you're going to need to do much. A 7.8, 7.7 graphics card is pretty easy to hit. 7.9 might be a little tricky.
So it's really about kind of heat and noise at this point, I would assume, right? So, Scott, I'm guessing you're going to need 2 cards for all the monitors. So that's a fair bit of heat inside that case, right? And I was reading a little bit about how to water cool those, and it's even recommended that you put them on a separate loop from the processor if you're doing serious overclocking. So you're talking about 2 water cooling units.
Mm-hmm. But remember, to the point of the people on the blogs, we want to build the ultimate developer machine. I want to make sure that we don't accidentally start hooking up blue tubes of crazy liquid flowing around without remembering that the goal here is to compile code, not to play Counter-Strike.
So there's some other video cards that it looks like on the WEI Share stuff are not that 480, but they're a little bit lower, and they're still doing pretty well.
Okay.
Right, so I think they were like a 200-something series, and so those might be a better choice.
Okay. Well, so when we're talking about the developer machine, the compiler is still single-threaded, at least the one that we're using. So clock speed's important. Multi-threading and like having like a hexacore machine is important because we're going to have Outlook and Twitter and compiling all open at the same time. Memory is important because we might have virtual machines. We're going to have piles of things. We don't want any memory pressure at all. So 12, 16, 24, somewhere in there. Because we're looking at IE9 coming, and that's going to have 3D inside it, we're going to want to have our 3D graphics a little higher than maybe it sounds like I expected. But compiling hits the hard drive. That's the thing. Scott Guthrie has consistently said that if you want to make Visual Studio faster, or the perception of speed at least, get a fast hard drive. Everyone knows that we need an SSD, right? We all agree that SSD is the way to go, right? What SSDs can we afford, given that we may be spending $1,000 on a processor?
Well, I mean, the SSD you're gonna pay for, particularly if you try to do the RAID setup. Do we have anybody on the site so far who's been able to hit 7.9 without going to the RAID array?
It's hard to say because the numbers there don't really tell you if it's RAID. But if you look at the size of the drives, you can kind of infer that there might be one or 2 or more SSDs involved.
Right.
Okay. So I'm concerned about the RAID array because I understand it doesn't support trim, and that bothers me.
So what is trim, and why do I care?
So trim is really a way to clear blocks of memory on that SSD so that it can be used. You're going to end up really slowing down your performance if you don't have trim support. That drive is going to degrade in time.
Okay, so I haven't seen an SSD yet that's within our budget that'll do the 7.9. So Is this something that it would be dumb to actually get the 7.9, and we'd be better off by just going with like a 7.7 or something?
Yeah, I mean that Intel M25 is a beautiful little box, and it does great. And you can probably get 7.7, something like that, out of it.
Yeah, I do have to admit I'm pretty nervous about striping two SSDs. Even with the trim stuff aside, it just seems like I'm really asking for my whole machine to not boot the next day.
And that is the thing about SSDs, though, isn't it? That when they die, they don't die in a quiet way. They just simply don't work anymore, right? It's not like, a sector's bad, I'll not worry about that sector.
That's a feature I wasn't aware of. Thanks for scaring me.
Well, I mean, it's memory, right? It's just this big old pop of memory. And I know there's errors all the time on hard drives. There's errors all the time on SSDs. But as I'm understanding, with a hard drive, at least when the thing is spinning the rust around, if you hear a couple of clicks, it's like, okay, it's time to think about maybe getting another hard drive in the next 24 hours. But with an SSD, it's just, boom, sorry, it doesn't work anymore.
Yeah.
So we assume that as good developers and good people, we all have backup plans. But if you put a striped array together, you really are saying that, let's just double the chances of something going wrong, and let's tie the two drives' success to each other.
Right.
So I trust Intel, but I know that people are getting 7.9 on a Crucial. But Crucial makes good memory, but I don't know them from an SSD perspective. I think I'd feel more comfortable going with an Intel drive with trim support, and I don't know. I trust Intel. Is that illogical?
I think
it's a good idea.
That's how I chose mine. It was I knew that was just a nice box and got good reviews, and I decided that was the one I wanted, and I didn't want to trust anybody else.
Plus, Scott, I think, of all the things that we're looking at here, SSDs seem to be the technology that's moving the fastest in terms of performance and kind of new approaches and everything. And so it seems to be the least sane place to dump a boatload of cache.
Yeah, that's a good point. I mean, we know that they're good. We know which ones are good. Anon-Tech and Tom's Hardware. The data around SSDs is pretty much well understood, and that is a part we could potentially update in a year or two, assuming that it'll get even faster.
Yeah.
It sounds like, though, that there really isn't an off-the-shelf single SSD that's going to guarantee us a 7.9, and I don't really feel comfortable striping SSDs. Although, if I stripe my SSDs, will that literally get me like not a 7.9, but like a 15.8? I mean, is it going to be that much faster?
No, I don't think so.
It's not twice as fast.
And don't forget, Scott, if you have the coin, it's only $10,000 for 1,400 megs per second.
I know that you want the OCZ, the $10,000 SSD. But I guess my question is, with the RAID, I'm going to have to start thinking about, am I using onboard RAID? Am I buying a RAID card? And at this point, I'm effectively just talking to a RAM disk, I assume, if I had like two Intels in a stripe.
Yeah, if you use onboard RAID is a whole separate discussion from the dedicated RAID cards. But a good RAID card with onboard processing and onboard cache will also set you back I think they're anywhere between $5,000 and $1,000. Mm-hmm. And the onboard stuff is good enough for most folks, but it uses system resources, it uses system memory. It's kind of like remember when Win printers came out and the printers used to actually have smarts before then? Well, these are sort of the same thing.
Okay. All right. So it sounds like if I'm going to get a 7.9, we're going to need a quad or 6-core processor that's overclocked into 4 gigahertz range. I think it'll probably be that i7 that we talked about before. We might have to overclock that a little bit and do a little water cooling, but certainly not required. I mean, I could just probably get a 7.7 or 7.6 just fine running that without water cooling. We'll probably get an SSD, the Intel X25, maybe the Extreme Edition if we can afford it, right? Run that as our primary drive, and then get a couple of data drives that we can, some spinning rust. Maybe we could do that in a RAID for our data drives. Some new NVIDIA video card, probably the 480. And since they do run a little bit hot, I know that there's a whole religious argument between ATI and NVIDIA, but ATI lost me 6 years ago with bad drivers, and I just haven't come back yet. I'd be interested from the listeners what they think about the video card. But if we can get that into the water cooling loop.
Same thing here. It was the bad drivers about 6 years ago.
Yeah, I mean, it's just too many blue screens. It's like 99% of my blue screens were video driver based, and I've never had a blue screen on an NVIDIA in the Windows 7 timeframe. And then I think at least 12 gigs of RAM. The one thing that I always feel like I don't have enough of is RAM. And then actually one other thing about the SSD, we've got to have a 256 gig C drive. I mean, trying to get everything I need running in 128 gigs is going to be just too difficult. So let's price that up, Pete, and we'll put that on the show notes and write another blog post with our final list of what we're gonna buy, and we'll get more criticism from the group. One last question I want to leave you guys with, so you can maybe each of you can answer it separately, is that we're developers. We're not Anand from Anand Tech or Tom from Tom's Hardware. One of the greatest comments that I got on the blog post was that this seems like a bunch of SQL guys trying to build a user interface. You know, it's like they're probably going to get it done, but it's hard to really watch them do it. Did we make a mistake by not just talking to someone who can speak to this at the really, really detailed level? Or is it okay for a developer and maybe a listener who's not a big hardware guy to put together a machine like this without expertise, deep expertise in hardware?
This is Jeff. Can I answer that first?
Please, Jeff.
Because I'm not an expertise in hardware, but I absolutely love to put together my own machines, and I think that you learn a lot doing it. And if I just went out and asked somebody, well, tell me what to build, there's no interest, no excitement, nothing. I might as well just ask them to build it and give them a couple $100 extra. I really enjoy building the machines, and I learn a lot doing it.
Okay.
Yeah, this is Chris. I've got to say pretty much the same thing. You learn by doing, and you can do some research. You can figure out how it's put together. It's a fun and interesting experience, and the computer will just mean more to you because you built it with your own two hands.
Definitely. Pete?
Yeah,
Larry?
So, I've built every machine that I've had since the 286, and I get a lot of enjoyment out of actually building them. So I think it's at least as enjoyable to learn something new, which is why I want to do water cooling this time. I've never done that before, as it is to just go and buy something and have it run really well. So I'm really interested in building this myself.
Okay. Larry Larsen.
Yeah, I've always built my own machine. I've never had, as far as a desktop, I've never had a store-bought machine. So I look at it like, it's like a Jedi not building his own lightsaber. It's something that if you're a rookie, you have to do it. So I've just always built my own.
Stop. You have to build your own lightsaber. There you go, my friends. That's the quote of the show right there, is that you may not be a good Jedi. You may be one of the slightly less competent Jedis, but for God's sake, build your own lightsaber, my friends. Thanks so much for coming on the show and talking about the Ultimate Developer PC. We may not know what we're doing here on the Hansel Minutes, but we're having fun doing it, and I really appreciate everyone's time.
Thank you.
It's been my pleasure. Thanks.
Thank you.
All right, this has been another episode of Hansel Minutes, and we'll see you again next week.